Oh, hi! Welcome! My name's Mrs. Russo. Today we're going to be reviewing the atmosphere. Now, as you can see, I was reading a book about the weather. Now, the atmosphere and the weather have a lot to do with one another, but we'll get into that later. First, let's talk about what the atmosphere is, its contents, and what it's made up of. Now, the atmosphere itself is our protector, our shield. It protects us from dangerous UV rays from the sun, as well as the intense heat the sun does provide. So let's take a look at a little bit more about the different layers of the atmosphere. First, let's focus on some key words that we're going to be discussing over today's review. Atmosphere, which is what we're going to be talking about overall. Troposphere, your first layer. Stratosphere, second layer. Ozone layer, which is found in the stratosphere. Mesosphere, which is our third layer. Thermosphere, which is our fourth layer. We're also going to be discussing auroras, altitude, solar radiation, exosphere, and ionosphere. Now let's talk about the atmosphere as a whole. The atmosphere itself is a fragile envelope. Now, there's a reason we use the word fragile. The atmosphere can be destroyed. So it's our job to try and protect it, which is why we need to understand what the atmosphere is and why it's so important to us. Now, the atmosphere itself contains a variety of gases. There are two main gases, though. Your oxygen, which takes up about 21%, and your nitrogen, which takes up about 78%. Of course, if we combine those two numbers, we get 99. So there's still 1% of gases left. These are known as trace gases, which are just basically all the different other gases that get thrown up into the atmosphere. The atmosphere itself, as you saw from the key words, have several different layers. Each layer will differ in temperature, density, as well as the amount of certain gases present. Let's take a closer look at these layers. As you can see, the layers build one right on top of the other. You start with the Earth, and the first layer you're going to see is your troposphere. Your troposphere is where most of what we do happens. Your next layer is your stratosphere. The third layer is your mesosphere. The fourth layer being your thermosphere. Your exosphere is the one layer that really isn't a layer. It's actually the outer edge of the thermosphere itself, but we'll get into that a little bit more later. Let's first take a look at our very first layer, the one nearest and dearest to our hearts, the troposphere. The troposphere is the closest layer to the Earth. This is where clouds, wind, rain, and snow all occur. It's crazy. It's where we live. It's what goes on all around us. Now, the troposphere is the greatest density. Let's think about why that happens. You have the stratosphere, the mesosphere, and the thermosphere all hanging out on top of the troposphere. So let's say I'm the troposphere. First, you put the stratosphere on me. Then you put the mesosphere. Then you put the thermosphere. Now, I have all this weight pushing down on me. This is making me a lot more dense. What that means is I now have my same amount of mass, but I'm in a much smaller space. This is why the troposphere is the greatest density of all the different layers. Now, something very strange happens with our troposphere. As we increase in altitude, now altitude is one of our key words. What do you think altitude means? Excellent, it means height. So an increase in height decreases in temperature. It's a little odd. Let me think about that for a moment. I've gone mountain climbing before, nothing dangerous, and I noticed that as I went up the mountain, the temperature got a little colder. I had to make sure I was wearing something a little bit warmer. Wonder if that has anything to do with it. It does, because I'm increasing in height. I'm increasing in altitude. So the temperature in the troposphere is decreasing. It's the same reason why if you're in an airplane and you touch the window of the airplane, the window's cold as you go higher up. Now the tropopause is the top of the troposphere. It's the layer right before the stratosphere. The reason we call it tropopause is because of the word pause. It's basically stating that the temperature drop stops right there. It actually stops at a very cold negative 55 degrees Celsius. You want to keep that one in mind. So now that we talked about the troposphere, let's find out a little bit more about the next layer up, your stratosphere.
It will feel like a brand new bed every night for years to come. Welcome to Deprivation. And Planet. On the next Dr. Oz show, Dr. Oz is next. The 50-state 90-day challenge to have your best dad ever. Monday at 3 on Fox 5. There's no secret to building vehicles that retain their value. You design.
The stratosphere, as we said, is the layer above the troposphere. It starts at about 18 kilometers and goes all the way up to 50 kilometers. Now your stratosphere is oxygen deficient. Wonder what this means. Well, oxygen is what we breathe. And deficient means it's not a lot there. It means that the stratosphere does not have a lot of oxygen. Oh, I definitely wouldn't want to live there. I wouldn't be able to breathe. Now there's also a little bit of water vapor there. So there's not that much oxygen, and there's very little water. Well, it definitely means that I can't breathe or live there. It also means we won't have any storms. So nothing happens in the stratosphere. Or does something happen? Well, something does happen. First of all, as the altitude increases, the temperature increases. So this is the opposite of the troposphere. It goes from negative 55 degrees Celsius. Now remember, we talked about that the troposphere tops off at negative 55 degrees Celsius. And it goes all the way to 0 degrees Celsius. Well, that's still freezing, but I guess it's not as cold as negative 55. Ozone. Ozone is 3 oxygen molecules. Ozone absorbs solar radiation. That's right, the stratosphere has the ozone layer. Excellent. The ozone layer is the most important layer that we have. If it wasn't for the ozone layer, all the UV radiation from the sun would come down and get us. So even though we don't really have storms or anything crazy happening in the stratosphere, it is extremely important, if not the most important layer. Now, I would think since the ozone in the ozone layer absorbs solar radiation, that's the reason why there's an increase in temperature as we move up in height or altitude. That makes sense. I'm glad you can help me out with that. Now let's take a look at the next layer. Our third layer is the mesosphere. Now this layer is above the stratosphere, which means it starts at about 50 kilometers and goes to about 80 kilometers. Now, the temperature in this one will decrease as altitude increases. Didn't we already talk about a layer like that? That's right, the troposphere. So the mesosphere and the troposphere are very similar as far as the temperature decreasing as altitude increases. But I wonder how cold it gets. Let's take a look. Our thermometer, ooh, he looks mighty cold. Oh my goodness, it goes to negative 80 degrees Celsius. Oh, that's gonna be cold. I can't believe it. That's the lowest temperature in all the layers of the atmosphere. Well, you know what? I think we should take a break for right now so I can warm up a little. And what I mean by break is you can hit the pause button and get a drink or something. I'm gonna go stand by a fire.